Next, we'll move to the intakes. So when we move to these other ones, like the intake, the indexer, and the lift, they're all on buttons rather than these axes here. So you're going to have to use if-else statements. So we'll have if, and we'll do controller1 dot, we'll go button A dot pressing. You want to use dot pressing because, oh shoot, because pressed is a completely different function. We'll have, and we'll label these real quick. This will be the drivetrain. Labeling does help. I never did it, but it'll help keep things organized. So this is the intake. So intake. If controller1.button A is pressing, then left intake motor dot spin dot fix direction type forward, and we'll go at 50 vex velocity units dot RPM. Nope, double-colon RPM. Now we have to put an actual value here because there is no range. A button, whenever there's a button, so we have, say we have button A here, if it's pressed down, I won't write that. If it's pressed down, it'll either, if it's pressed down, it's 1, if it's not, it's 0. So a button only recognizes two values, 1 and 0. So then we have the pressing here, so it's recognizing 1. As long as it's recognizing 1 here, it'll be going at 50 RPM. And we can just copy this right here, since we want these to go in the same direction, both intakes, as long as you have them set up correctly. You want them both to go forward at 50 RPM. And then else the left intake motor dot stop. And you don't have to put a specific stop here. Oh, because they don't need to stop and brake or anything, they can just stop. And we'll do the same thing here with the right motor. And then you'll be like, wait, how do I get it to go backwards? Well, you'll just use a different button and you'll have to add an else if statement. So else if controller1 dot button B dot pressing nope. And then we'll just copy this right here and we'll add in reverse. Oh, I forgot parentheses. So now we have the intake code, and now if you press A, it'll intake. If you press B, it'll outtake, and if you don't press any of them, it'll stop. And it's pretty much the same theory for the indexer and the lift. So you'll just do the same thing, type different words, and it'll be the same. Another thing that you guys can use, you can add this. So you can add an integer. So you just type int, and then we'll add the integer. We'll call it num for number. And we'll make it equal to 50. Nope, not 5-50. now it's going to yell at me, right? Unused variable num. It's just telling me that I have not used that variable anywhere. So why is it even here? Well, I can just use that here, and I can just put num into all these. And if I want to make it go faster or slower, I can, so if I want to make it faster and I want to make it 70 RPM, I can just put it as 70 up here, and now all these are going to be moving at 70. If I want to go slower, I can make it back to 50, and it'll be 50 down here. And that's pretty much it for user control. You can just mess around and do other things. If you need, if there's a little bit of dissonance in the drivetrain because the controller isn't like centered perfectly, because sometimes the joysticks for these here will not be perfectly centered and will have a little drift, so you'll have to make it an if statement. So you'll put controller one dot, say it's just axis 4 is less than we'll say greater than, yeah, we'll have greater than 15, and then you'll have to put an OR, which are two straight up lines. This is OR and this is AND. Double AND sign is AND. Double straight up and down line is OR. And then you'll have controller one. Oh, dot position. I forgot position. And dot axis for dot position is less than negative 15. Nope. It'll allow you to use this as normal. And I don't think you even have to put an else statement here, because it's not going to do anything if it's not in this range of 15 and negative 15, because the things register from 127 to negative 127. So that's it for user control, and then we'll move on to autonomous next.